So this video presentation is a brief discussion about the CMOS process integration. So first, let us define process integration. Process integration is what we call the combination of sequence of these unit processes to fabricate integrated microelectronic circuits. And there is a technology, what we call the CMOS technology. And this CMOS technology is a complex arrangement of unit processes, and several hundred steps are required to manufacture integrated circuits on a silicon wafer. Okay? And we mentioned unit processes. The combination of these unit processes results in the formation of these what we call the integration modules. Okay, again, CMOS technology has unit processes, and from the combination of these unit processes we form integration modules. And then again, if there is the combination of these integration modules, the overall process flow or the process sequence will be produced or will be formed. Or in other words, this overall process flow is the combination or results from the occurrence of this what we call the integration modules. Now, overall process flow can be divided into two divisions or in two parts. The first part is the front end of the line processes, or abbreviated as the FEOL processes. Okay, and the other division is what we call the back end of the line processes, or the BEOL processes. Let us first discuss what are these front end of the line processes. Front end of the line processes. So these are all processes preceding silidization. So what is this silidization? Silidization is basically a process that results in the formation of metal silicon alloy that acts as a contact. Okay, this front end of the line processes also includes all the processes required to fully form isolated CMOS transistors. Again, it also includes all the processes required to fully form isolated CMOS transistors. So in this case, let us enumerate some of the processes or the processes that are included in the FEOL processes. First one, we have this starting material. Second is the shallow trench isolation, or the STI. Third is the well formation. Fourth is the gate module. Fifth is the source or drain module. So let us first describe the starting material, or the first process under the front end of the line processes. So here, literally, you will choose the starting material for your job, or for your work. For example, what type of silicon wafer to be used. Okay, so here you're going to decide what is the type of your medium. Okay, The second process, the shallow trench isolation or the STI. These processes are done to form the regions of dielectric, again, the regions of dielectric between regions of active area. Okay. The third is the well formation. Wells are also called tombs. Okay. These tombs are formed followed by the gate module. And now, gate module includes processes to properly define gate electrodes on a thin oxide. And then the last process under the front end of the line processes is the processes under the source or drain module. Okay. This module includes unit processes required for the formation of the low dope drain extensions. Again, these are the unit processes required for the formation of the low doped drain extensions and the source or drain regions themselves. So now, let us go to the back end of the line processes, or the next division of the overall process flow. Okay. So what are these back end of the line processes? So these are all the processes subsequent to source or drain formation. And in these processes, wiring is present. Wiring is done in this process. And what would you wire in these processes? In these processes, there is the presence of the wiring of the transistors together using multiple layers of dielectrics and metals. Okay? So, wiring basically using layers of dielectrics and metals. So you would notice that the first process under the second division of the overall process flow is the silicization, and followed by the pre-metal dielectric, or the insertion of the pre-metal dielectric, PMD, followed by the contact module. Next is the metallization 1. The next process is the intermetal dielectric. So just like the second process, there is again the insertion of a dielectric material. Okay, and as you can see at the seventh process, metallization 2, there is again the process of metallization. So we therefore conclude that the back end of the line processes starts with the silicization, and the remaining BEOL processes proceed in repetitive sets of modules to yield lateral and vertical interconnects isolated from one another using dielectrics. So here is the proof. We used two kinds of dielectrics, the PMD and the IMD. And in these back end of the line processes, or in these BEOL processes, there is no trivial process change happening. Okay, there is the absence of change in the processes, as in there is no change. A trivial change in one unit process can have dramatic effects on the processes in the modules. So for example, if you change a unit process, the other processes would of course be affected and might result to failures and other scenarios that are bad or that are even worse for the production. And now we will now proceed to the next topic, CMOS process description. So basically, CMOS process description, we will just describe again what we have discussed, because CMOS process consists of the two divisions of the overall flow process, or the overall process flow. So again, these two divisions are the FEOL processes and the BEOL processes. And in describing a CMOS process, there are what we call the process schemes. Okay, different devices, different process schemes, or even in a single device, there are numerous process schemes. Okay, but in this scenario, or in this discussion, we would use a generic CMOS process flow. And why are we going to discuss or use a generic CMOS process flow? Because it is impossible to outline all the process schemes. Even if you are just going to describe the process schemes in a single device, it is impossible because of its number, okay, because of its large amount. So our CMOS technology will have the following features. For the front end of the line processes, just have the 4 processes. So the first one is the shallow trench isolation. Second is the twin tubs. Third is the single level polysilicon. And the last one is the low doped drain extensions. So remember the processes that are included in the slides a while ago of the front end of the line processes. On the last discussion, there are 5 processes, and here they are integrated into just 4 processes. This is just again a generic CMOS process flow. So basically, it is general. Okay. Now let's go to the back end of the line processes of a generic CMOS process flow. So again, they are again minimized compared to the other one. Now we just only have 3 processes. First is the fully planarized dielectrics, or planarized dielectrics.
So now,
second is the planarized
some
tungsten
conceptual
contacts and
figures for
via
some of the
plugs.
processes
The third one is the
or
aluminum metal.
specific objects or subjects included in the CMOS process integration. So we have here the shallow trench isolation, and then an image of a silicon wafer and a metal silicon alloy. We also have the twin tub formation and the low-doped drain extensions, and lastly, conceptual figure for metallization. So this ends my presentation. I hope that you learned something, and thank you for watching.